Good morning, everybody. My name is Vishnu Dutt, and as you know, we are talking about session number 5th of Cisco Certified Network Associate, right? Or CCNA class. So I'm pretty sure that in starting 12 to 15 hours, which we have already spent, you must be pretty sure about how two computers talk when they are in same network. If I say they are in same network, suppose we have these two computers, A and B. If they are in same network, then they must be connected with a switch. You can argue with me that if these are only two devices, why do we need switch? I can connect them directly. And yes, you can. But what if you are going to have another computer, which is C? Then you must be having a device which can connect all these PCs together. And that is why we use switch. You all know for sure that what is going to happen if we have two different networks altogether and we have two different hosts in these two networks, how these two hosts are going to communicate. And you all know that in this case, we are going to need a router because router connects multiple networks. If whatever I said in last 2 minutes doesn't make sense to you, it means that you have missed some of the classes. So I request everybody to go on bridgewire.com or YouTube channel to revise all those starting 5 classes from 0 to 4, right? And I want to make sure that if you have seen these theoretical classes, these are going to be your base because whatever we are going to read from now on, it is just going to be making the network more efficient. Network we have already built. If you know the process how two computers talk when they are nearby or miles apart, then basically you have won the battle of networking. So if the initial 12 to 15 hours excites you, then basically I would say networking is going to be very, very easy. But if those doesn't make sense, then I would say that you need to make sure that you go them once again. Having said that, why 15 hours of theory, right? 15 hours of theory is absolutely mandatory to begin even a simple lab of networking. And here we are going to cover some practical stuff, right? What is the meaning of practical stuff? Whatever we have learned till now, what we are going to do, we will be trying simulating them into a software, and the software name is Packet Tracer. Okay. The mode of communication during this meeting is going to be same. If you have any doubt, any question, please raise your hand. Interrupt me in the middle, but do ask your questions. Okay. So I was talking about Packet Tracer. Packet Tracer is a software which can help you basically working or dealing with routers or switches. So there are two modes, right? One was that I can assign you maybe two routers, two switches, and those are going to be the physical devices. But believe me, we do not have that kind of budget because routers and switches are quite costly. And I can see that there are more than 200 people in this CCNA training, right? The second option is that if we can have a software, right, which can simulate the experience of routers and switches, then it is going to be great. And believe me, the Packet Tracer software is too good. I will showcase you that how you can begin your journey in networking practicals using this software. The name of the software is Packet Tracer. You can download it from Cisco networking site. You just need to write download Packet Tracer. I just opened my browser, and if you see here, I am writing download Packet Tracer. And the first website is going to be download Packet Tracer network simulation tool. If you go here, you just need to make sure that you are logged in into this uh, portal, right? And if you log in, then under the resource section, you need to just download Packet Tracer. Doesn't matter if you have Mac laptop or the Windows laptop, you are going to have a download file for that, right? For example, if you see here, we have Windows desktop version. Let me open the pen also. Just wait a minute. Okay. So if you see here, we have Windows desktop version right here. We have Ubuntu desktop version. If you have by any chance Ubuntu machine, or if you have Macintosh operating system, we have also the downloadable file for that, right? You just need to download. Uh, it is just like as any program you want to install on your machine, right? Just download this file, install this program, and you will be good to go, right? But before coming into the UI of this great tool or great simulation tool, I want to explain you that what we are going to do in this in today's class, right? So today's class is going to be distributed into two parts. First, 1.5 hours, what we are going to do, we will be learning about creating our own networks in Packet Tracer, or whatever we have learned in this 12 to 15 hours of studies. We are going to see them live on the devices, that how packets actually move between routers or switches or between two hosts, right? So this is the topology what we are going to build in this packet tracer. Not only the topology, we will see how packets are going to come out from this host A, will reach to switch, maybe to router, and to another other hosts, right? So this is the complete topology which we want to draw with complete explanations also, right? So if you see this topology very closely, if you see on the left hand side of this router, we have a simple network, right? In this network, we have one switch, switch one, and then we have host A, host B. If you see, I have configured the IP address also for the host A. Host A IP address is going to be 192.168.10.10/24. And by this time, you should be understanding what is the meaning of 192.168.10.10/24, right? You all know that if the subnet mask is /24, the meaning is starting 3 octets are defining your network, and the last 1 octet is defining your number of hosts, right? So basically 192.168.10.0 is the network number of this network. You all know, right? And then I would say I have taken out of those 256 addresses, which is possible here from .0 to .255. You all know first IP address is reserved for the network number. Last IP address is reserved for the broadcast number, right? So 254 addresses we have, and out of those 254 addresses, I have given one address to host A, which is 10.10, and one address to host B, which is 10.20. The important part is host A and host B are part of the same network. You should understand this to begin with, right? So if you can say I have a complete network on this router's left hand side, this is going to be the discussion what we are going to start, right? So I will draw simple one switch. I will connect two hosts to it, and you will be amazed to see that these hosts are going to communicate with each other, right? And we all know why. We all know that address resolution protocol will come into picture. Why? Because at the beginning, host A does not know the MAC address of host B. And that is why we are going to start with address resolution protocol, which is going to give me the MAC address of host B, right? So everything, whatever we have learned in the layer 2 and layer 3 packet war, we are going to see everything live today on the packet tracer tool, right? Similarly, if you see here, we have another network, this one, and this network is totally different network. Why? Because we are talking about 192.168.20 network. The third octet of this network is different than the green network, whatever I have drawn here, right? This is 20.0/24. And you all know that this is going to be having 254 addresses which we can use inside this network. I have given dot 10 means now this is 20.10 for host C. And then basically for host D, we have 20.20. It is as simple as that, right? MAC addresses you can see I have given pretty easy for host A. For for host B, it is B. You can understand the remaining one, right? So what we are going to see today is first thing first, we will be starting with this green network. We will connect two hosts into this with this switch, and we'll try what happens behind the scene, right? Then I will be introducing a router, and I will be introducing another switch with two hosts. And then we are going to see that how host B or host A can able to communicate to host C or host D in different network. Now these two networks could be in totally different part of the world, but you know that if they are different part of the world too, they can talk easily, right? With the help of this router, because the router's responsibility is to connect multiple networks. It is as simple as that. So by the way, I would need at least two volunteers for today's class, right? And I can call anybody. So it would be great if everyone, whoever is here in the meeting, can just pay close attention towards it, because I can call anybody for my help, right? And do not worry, that help is not going to be, I'm not going to test your knowledge, but you are providing me your help, right? For example, I would say that if the packet color is green, just remember that this basically our packet color is green. That is it, because we are going to see the simulation live today. Okay. Having said that, as I mentioned that you need to install the packet tracer, and how to install, you just need to log into Network Academy site, just download that downloadable, right? Install packet tracer on your machine, doesn't matter what machine you have, right? We have the uh, exe or DMG file for what we can say different operating systems. So do not worry about it. Having said that, I would like to tell you that what you are going to see in Packet Tracer. So this is my actual topology which I want to build, but in Packet Tracer, you are going to see this thing like this. And this is quite simple too, right? I would say that I have drawn this switch here, then two hosts, host A and host B. So first thing first, I will start the packet tracer, and that is not going to have anything in that, right? So we will build everything absolutely from scratch. So this session is for anybody who doesn't know ABCD of any simulation software. But I would say that you should have understanding of initial 15 hours to understand completely this lab process. Okay. So as I mentioned, this is going to be my first network. This is going to be my second network. First network is going to be 192.168.10.0/24. The second network is going to be 192.168.20.0/24. And you know that here we have the router. Router is connecting these two networks. So we will be building this network absolutely from scratch. But before that, I want to remind you few things, right? I want to remind you a few things from what we can say previous classes. And maybe there are some things which are new to you, right? So suppose I have a switch. You all know the switch functionality now. I'm not sure how many of you have Googled that how switch look. If you Google it, then basically you are going to get many images of the switch, right? Generally, what switch contains? Switch is going to have many interfaces, the Ethernet interfaces, right? But the question arises, how you are going to talk to this switch? It is as simple as that. Because switch means a hardware device, right? And if you want to make sure that it obeys your instructions, you need to communicate with the switch. And if I ask you the same question, what you do in case of your laptop, right? Your laptop is also a piece of hardware, right? But it takes your inputs, it does some computation on your input and provide you output. It is as simple as that, right? In the case of your laptop, what is going to be the input device? The input device is going to be your keyboard and basically the mouse pad, whatever you have here, right? And what is the output device? Of course, this screen is going to be the output device. Who is processing all your requests? Your computer's processor is executing all your requests, right? But actually, you cannot talk to the processor directly. You need some middle thing which can take your instruction, right, from the input output devices and give those instructions to the CPU, right? And that something is actually the operating system. And I'm pretty sure that you have heard about it that if we are using Windows, then Windows is just an operating system. What is the responsibility of operating system? It takes some of the inputs from you, right? Or basically you can say it is a bridge between you and your computer hardware. It is as simple as that. Doesn't matter what operating system you are using. You might be using Windows, you might be using Mac, or you might be using the Ubuntu or the Linux operating system, which is the mostly used. Maybe the Linux operating system is the widely used operating system across. I'm not saying not Windows, not Mac, but yes, most of the things have been built on the Linux, on top of the Linux. So overall, if I say operating system basically is a bridge between you and the computer hardware. And similarly, if we talk about switches or routers, you want to give some instruction to this router. For example, you must have read about how routers does routing, right? So although everybody comes with the default, but you want to change some of the defaults. And if you want to change some of the defaults, then what you need to do, you need to interact with these devices. And that is why Cisco has developed iOS, right? Internet Working Operating System. It is not the iOS present in the Macintosh operating system, right? Although the name is same, but here the I is capital, and we are talking about Internet Working Operating System, which is developed by Cisco, right? So although we have many flavor of this iOS nowadays, depending on the devices, whatever we are talking about, you can argue with me that Windows is same, irrespective of the device we are using. We can use HP laptop, we can use any other laptop, but the Windows is Windows. But yes, iOS development, we are talking about iOS, which was built in approximately, I think, 1985, 1990. So there are major developments in that. And that is why we have different flavors of operating system, but actually everything is iOS. But yes, depending on the need, we have different flavors of operating system, right? Just like Windows has XP, then Windows 8, 10, 9, right? Or 10. Having said that, I think you all agree with me that now Cisco, basically we are talking about iOS, which is going to be the operating system, which is sitting between you and this hardware piece, and that is Internet Working Operating System, right? So generally what happens, how you give your commands, of course, with your maybe any input output device, an input device which could be the keyboard. So basically you need to connect your laptop to this switch or this router. I'm talking about what is going to happen if we talk about the actual router or a switch. In case of actual router or a switch, you will be having a switch which is a physical device, and you are going to have a cable which is known as the console cable. If you connect this console cable with your laptop and give some parameters, what those parameters are, you can easily Google them out, right? But the whole sole point is, if you have a switch, you have your laptop, you can connect it with the console cable, and once you are done, when the switch is on, you are going to see a terminal window, just like any terminal window. For example, if you have an experience of working in the command line prompt of Windows, it is just a command line prompt, right? You can give your instructions and operating system is going to execute them. Similarly, What we are going to see here is when we connect our laptop with this console cable to the switch, it is going to give me a console, and inside that console, I can actually uh, and inside this console, I can actually uh, what we can say log in and give my instructions to these switches and routers, and switches and routers are going to obey it, because now you have something in the middle, and this is your operating system, which is your internet working operating system. You give commands here, switch is going to execute it. It is as simple as that, right? Just like any other system. So if you have any doubt with respect to whatever we have discussed till now, you can raise your hand. Otherwise, we can proceed. So anybody has any doubt, any question till now? I don't think there is. Okay, perfect. So, but in case of software, we do not need any cable, right? What we are going to do, we are going to have our laptop, the Windows laptop or the Mac laptop. What we are going to do is we are going to install Packet Tracer into it. And this is just like any other software program which you install or application. Once you install it, you can double click it, and it is going to give you a neat and clean UI, user interface, through which you can work on different routers and switches. Right? It is as simple as that. What are the nitty-gritties of internet working operating system? I will guide you when I log in into these devices. Do not worry about it. But as soon as you get into the console, right? As soon as you get this terminal window from the switch, it is going to give you this prompt. It is saying that this is a switch, and then basically it is going to say a greater than sign, right? This greater than sign means now you are into a specific mode of internet working operating system, right? And that mode is known as exec mode or execution mode. It is as simple as that. So what is the meaning of it, right? Suppose you have this switch, right? And you have this switch is very, very important for your organization. And in your organization, there are three different guys, number A, number B, and number C. So you do not know always the intention of anybody. Maybe Mr. C doesn't like you. He doesn't want you, right, to grow in its career. And maybe he can log into this device and he can wipe off all the configuration, whatever. And whatever the guys or the laptops connected to this switch, they are no more able to communicate with each other or uh, to the outside world. If that is the case, then there is a disruption in the services, and this is going to be problem for Mr. A, right? And that is why there must be some security with respect to who can do what activities on this switch, and that is why we have different modes, right? So first thing first, whenever whoever logged into this device, maybe if he is able to get the console cable, Mr. C or Mr. A, they are going to get this console switch and then greater than symbol, which is proving that it is an execution mode. And by the way, in this exec mode, you cannot do much things, right? So basically, you can see some of the configuration of the device, and that's it. And that too, very limited commands are enabled here. So Mr. C can see the switch, but he cannot do much thing. He cannot change the configuration, right? Unless he has some password, right? To go into a mode which is more powerful than the exec mode, you will see that mode with this hash symbol, right? And generally, people protect this mode with a password. So you need to provide a password here to log in into this hash mode, which is privileged mode. This is privileged execution mode. And in this privileged mode, now basically people can do whatever they want with respect to the switch, right? And of course, if Mr. C does not have this password, then they cannot go into the privilege mode. And if they cannot go into the privilege mode, they cannot change the configuration of the device. And if they cannot change the configuration of the device, this is what you need. It is as simple as that, right? So execution mode, privilege mode, inside privilege mode, if you do configuration T, it means that you are moving inside the configuration mode. It means that you can do whatever configuration you want. Maybe in the beginning it is looking overwhelming, but believe me, it is very, very simple, right? I just said that you are going to have the switches and routers. You need to control who can do what. And that is why you have different levels of modes, right? Now, number one is execution mode, which can be identified as greater than symbol. Any person who is into this mode cannot do much things, but you need to make sure that the next mode is protected with the password. The next mode is going to be the privilege mode. Inside this privilege mode, you can do whatever you want, and the symbol hash represent the privilege mode. That is it, right? So this is what we are going to see today. Now, what I am doing is I am opening the packet tracer. And what we are going to build? We are going to build this topology. It is as simple as that, this one. You must be thinking that why it is small, right? Because in the previous sessions when we provided, people have give us this feedback that it would be nice if we can see the topology and we can configure it, right? So this topology is going to be here. This is what we are going to build. If you want, you can just take a snapshot of it. You can just take a picture of this, right? So that you can refer to this topology when we are into the command line mode. So just try to understand, just try to make this topology in your mind, right? We are going to build first thing first, only this switch with these two hosts. We will be making sure that these two hosts are communicating, host A and host B. Then we will move forward. Then we will introduce router. We will introduce this switch and other host, right? But to begin with, what I'm going to start with, I'm going to create only one switch. I'm going to connect this switch with host A, host B. I will be defining all these parameters. And you all know that if I do not do anything on the switch itself, it will work, right? So let's open uh, the packet tracer and I will guide you how the packet tracer looks. Okay. So having said that, we are right here. This is the packet tracer software. And I want a hand raise that if you can see the packet tracer software. Can anybody confirm? That is perfectly fine. This is great. Thank you so much. Thank you so much. And if you see here, let me guide you some of the uh, things here, right? So basically, when you open this software, you are going to see this UI, right? And in this UI, basically on the left-hand side, left-hand bottom, you will see many devices here, right? So this is a router, this is the endpoint. Basically, this symbol is your cabling symbol, right? So what we can do is we can select whatever we need from here. We can put it here. And it is as good as that you are bringing a physical device, right? This is very, very interesting. And you do not need to work up, you do not need to pick that physical device to cable it because software is providing you. So you can say that this is your inventory here. Whatever you like from here, just take it and put it here in this portion, and there basically you can see that we have this topology created. Suppose I want a switch here, so I will be bringing a switch from here to here. I want two hosts. I will be bringing a host here and then connecting it with the cable, right? Another host, and I then will be connecting it with the cable. And then it is as good as that I have connected two real laptops with a switch, because it is going to behave like this, because whatever is running inside a switch, it is a real operating system, which is internetworking operating system. Do not believe me? I will showcase you, right? These are the laptops or the host or the endpoint, right? Which is eventually connecting to a network to gain access of internet or to talk to anybody else. It is as simple as that. right? So let's start building this lab. What we are going to do, I am again repeating, we are going to have one switch to begin with. We are calling this switch as a switch 1. I will be introducing two different laptops or host. I will be giving first host as name as host A, this as host B. I will be connecting them from here to here. I will specify the IP address of host A to 192.168.10.10/24 and the IP address of host B to 192.168.10.20/24, right? And then I will initiate the ping from A to B to see that whether I can able to ping or not. I won't be configuring anything in this switch, and you will be amazed to see that these two guys are going to communicate with each other. As simple as that. And then I will going to simulate that experience with you because we have a simulation experience also. I mean, this packet tracer is a powerful tool. What it is going to show you, if I do a ping from host A to host B, it will actually generate the ping message, right? But you know that you cannot send this ping message because if you have gone through the last lecture, there I can generate this ping message, right? IP packet. But it cannot go. Why? Because I need to encapsulate this packet into another layer, right? And where there is the MAC addresses. I do not know the MAC addresses of B. And if I do not know the MAC address of B, how can I send this packet over this Ethernet wire? And that is why this packet is going to store into the memory of this computer and ARP is going to be generated. ARP source and MAC addresses you all know. The source MAC address of ARP is this one. The destination MAC address of this ARP is going to be the broadcast address. This is going to be here, and this guy is going to reply. And we will be seeing all these things in actual simulation. This packet tracer has this capability. And believe me, even after 13, 14 years means I have spent in this industry, I was not aware of this capability of packet tracer to simulate such things. This is one of the great learning tool if you are starting in the network, if you are starting your network journey, and it will showcase you all the packets too, right? Having said that, enough talking. Let's talk. Let's draw something now, right? So what I'm doing here is I am first thing first. I am clicking on these network devices and specifically switches here, and whatever the first switch I find, I am introducing it here. I will write that this is my switch 1, right? Actually, I do not want to see this number, so can I change this? I am not sure. Okay, okay, just wait a minute. In the meantime, can anybody search on the internet to tell me that how to, if I do not want to show the model number of this switch, how to do that? So maybe the moderators. So I will, okay, so I have bring this switch here. Let's bring it somewhere here. And now what I'll do is I will introduce some endpoints. What is the meaning of endpoint? I will introduce this PC here and the another PC right here, right? So this is my simple topology. I have two switches. You can argue with me that why can't I connect these two PCs together? I can, right? We can. And this is going to be very, very easy. But suppose if I want to introduce one more host into my network, then I cannot connect, right? And that is why I'm going to need a device which is having multiple ports. Now I want to connect these two devices, right? These three devices. So I will take, although you must have learned about the crossover cable or a straight through cable, right? So suppose I have two PCs, PC number 1 and PC number 2. You all know that if I connect them through straight through means that we are sending on pins 1 and 2 and receiving on 3, 6. And both the devices are same. And if both devices send on 1, 2, then it is going to be problem. So similar type of device are going to be connected with the crossover cable, not with the straight through cable. You all know from the theory classes. But in that class, at the end, after wasting your, I think, half an hour precious time in the learning of straight through and crossover cable, I mentioned that today's switches, routers, and these hosts are pretty intelligent. They just see that from where they are connecting and they change their pin location. So you do not need to worry about that whether you are going to need the crossover cable or straight through cable. But if you can see here, this is your straight through cable and this is your crossover cable, right? If you want to test them out, please, you are more than welcome. But I know that in today's world, even when I joined Cisco, after that, I do not worry about this crossover or the straight through cable because the system or these devices are so intelligent that they understand that who is sending where and who is receiving where, and they accordingly change. It is as simple as that. So what I will be doing here, I won't be talking about these crossover and other cables. I will be just clicking on this symbol and I will be taking this guy and connecting here, right? It is very, very simple. Now my PC 0 is connected with this switch, and similarly, I'm going to do the same thing from here to here. Now my PC 1 is also connected to this switch. What I'll do now is I will change the host name, just like mine. Here I'm going to have host A, and the host name of this guy is going to be host B, right? It is very, very simple. And this is my switch. So what I'm going to do, and if I just hover over this switch, it is going to showcase me that how many interfaces are here. There are many interfaces. So this is a 24 port switch. You can see 0/1 to 24, and there are 2 gigabit ports also. But I'm not going to discuss much in the hardware details of it. Whatever we have learned till now, we will be talking about it, right? So here, what I'm going to do is now I will be configuring the IP address on host A and host B. So this is going to be my host A, this is going to be my host B. What I will be doing is I will be opening the console of this host A by just simply clicking it, right? And here, if you go into the config here, right? It will showcase you many things here. For example, it will saying that this is the fast Ethernet 0. So basically the port, whatever you are seeing here, this is FA fast Ethernet 0 port. Let me write it down. Or just wait a minute. I can just wait a minute. Edit options, preferences. I should say the view and logical view, toolbars. Can anybody search that? How can we show the interface name here? Anybody? No, yes? Okay, interesting. Because I have recently did it and there must be something here only. Anybody has any comments? Go to options here, preferences. Okay, here I can see that show device model labels. I don't want to do this. Do you see somewhere here interfaces also? Always show port label. That is great. Okay, thank you so much for the help. And here we can see, because I heard somebody in the crowd that they are saying just go into the options. Thank you so much for that. So you can see now it is making more sense. And now I will be going to this host A again. Here is the host A. Okay, so what I'll do is you can see I just click on this interface and I'm into the fast Ethernet 0. And what I want to do here is I want to specify the IPv4 address. So let's specify the IPv4 address, 192.168. Okay, okay, now it is doing 192.168.10.10. This is going to be the IP address, and the mask is going to be /24. And you should understand that 255.255.255.0 means /24. It is as simple as that. This is what I want to configure. But along with that, if you can see here, uh, there is a field which is called MAC address right here. And here we can change the MAC address too according to our topology. So what I'll do is I will change the last four numbers here to match my topology, right? Which is going, and it is not the requirement, guys. I just want to show here that we can change it, and so that we can easily identify the MAC addresses. If it is the last four digits are A, it means that it is going to be host A. It is as simple as that, right? So I have configured just the IPv4 address name, subnet mask here, and along with that I have configured the MAC address too. In fact, the last four digit of this MAC address. If you see that whether these changes are there, just go to this desktop. I was in config, just go to the desktop, just click on this command prompt, and you will be seeing here, if I do ipconfig here, this is the command ipconfig to know. This is just your Windows machine, just like, right? And it's a command prompt of Windows machine. What I'm doing here is I just written ipconfig. This command is going to give you what are the IP address you have assigned on this for this host. Right now I'm on host A. So basically you can see here that I have given IP address as 192.168.10.10, and the subnet mask is this one, right? If you want to see the MAC address parameters here also, then what you need to do is you just need to write ipconfig/all. If you do that, you can see that the MAC address right here, which is going to say A. Do not worry about this IPv6 portion for now, right? This is another protocol like IPv4, but it's a new protocol. It is having some extra features than the IPv4, and it's a tremendous protocol, right? We will be talking about it. So physical address is this one, and the logical address or the IPv4 address is this one. It is as simple as that. The same thing we are going to do with host B also, right? So we are into the host B. Now again, we are going into the configuration of host B. Right here, we will see fast Ethernet 0 port of this one, right? And we will be typing the IP address. Before that, this is going to be my host B. So what I'll do is B here, very simple. And now here 192.168.10.20. The meaning is that these two hosts are part of the same network, right? And the network name is 192.168.10.0/24. It is as simple as that. Let's check whether the configuration is there or not. Let's go into this command prompt of host B. So by the way, whenever you click on this machine is going to tell you that you are now into host B, right? Previously, I was in host A. It is as simple as that. So if you see here, let's run the same command again, and the command is ipconfig. Here you go, 10.20 is the IP address. Very simple here, right? And if you do ipconfig/all, you are going to see the MAC address too. Here is the MAC address, right? This one is the MAC address because I have changed the last four digits to BBBB. It is as simple as that. Now let's see whether these two devices can communicate to each other or not, right? So as you all know that first thing first, now let's talk about what is going to happen, right? So if I say that suppose I am in host A right here, what I did till now, I have assigned the IP address 192.168.10.10/24 here, and 192.168.10 10.20/24 here. The MAC address of this one is A, the fourth last digit I'm talking about, and this one is B. What I will do is I will do a ping from host A to host B to check whether I'm able to reach to host B or not, right? So what I'll do is I will generate a command. I will write a command into host A, ping 192.168.10.20, right? I am in machine 10.10. I want to check that whether 10.20 is reachable or not. First thing first, this host A will check whether this destination, which I'm trying to ping, is part of my network or not, right? And definitely this host can do. Why? Because even you can do now. You know the subnetting, right? You can straight away tell that 10.10/24 is my range, right? 192.168.10.10 is my range. And now host A knows that from dot 1 to dot 254, I know that these are going to be the IP address in my network. Then of course 10.20 is part of my network because I know that I have subnet mask of /24. And that is why you define subnet mask here, because you know that host A is going to need it, right? Why? Because whenever host A wants to ping or wants to communicate to any other host, first thing first, it is going to check whether the other host is part of my network or not. And it can know only if you specify the subnet mask along with this IP address. It is as simple as that, right? So from here, it is for sure that host A comes to know that host B is part of my own network. It is going to create this ping packet. The source of the ping packet is going to be what? The source address of the ping packet is going to be 10.20, and the destination address is going to be 10.20. But to send this IP packet over, and of course, there is a ping message inside it. And to send this IP message over this Ethernet interface, you cannot send like as it is, right? You need to encapsulate this packet into another layer, which is your MAC address. You need to put source MAC here and destination MAC here. Source MAC is going to be A. And here is my problem. You cannot figure out what is the destination MAC because you do not know what is the physical address of this machine. I know only the logical address of this machine. If I say logical address, that's the IP address, right? And that is where basically most of you have heard about that. Why do we need two addresses here? And I have specified that answer too. If you are not convinced with the answer, actually the discussion of this answer, that why do we need MAC address along with the IP address, need at least 1 hour of explanation. And I have a dedicated video for that. If you just see the basic series of my on my bridgewire.com, right? There is a question, right? There is a series of questions. And in one of the question is that why do we need MAC address along with the IP address? There is a 1 hour discussion. If you are interested, you are more than welcome to watch it. But that is going to be very, very important, right? But we all know that we cannot fulfill this complete frame, and that is why it cannot go over this wire. And that is why this host is going to store this complete frame into its memory, and it will say, it will send an ARP message. ARP message is going to be the even this message is not going to come out, right? Because this will be in the memory of this computer. This ARP message will be generated by this host A. It will be sent over this interface, and the broadcast address, and you all know the ARP message is going to be the broadcast address. The switch will be forwarding it here, and of course to any other host which was connected to this switch, right? Doesn't matter, maybe C, D, E, F, whatever, right? Interesting. The broadcast message will come here. Host B is going to reply with the MAC address, and this way this guy come to know that, okay, now I know that BBB is the MAC address corresponding to IP address 10.20, and then this address will go, right? You do not need to do anything here, right? But first thing first, I need to check, right? And to make this process more efficient, this host cache these entries. What is the meaning of caches? Suppose This host is talking to host B, and now this host know the MAC address of B. It will save this into a particular file inside this machine so that it does not need to do ARP again and again. It is as simple as that, right? So first thing first, what we are going to do is we are going into this host A right now here, and let's see what is there inside this file. You can check this entries of these MAC addresses using arp-a command, and it says no ARP entries found. And the reason is pretty straightforward because you haven't done anything till yet, right? If I talk about host B, right? Host B is also right here. If I talk about host B also and do arp-a, you can see no ARP entries found, right? And then what I need to do now is I am doing just the simple ping. I am in host A. I am writing ping and I am writing 192.168.10.20. What is my IP address? My IP address is 10.10. To whom I am talking to? Suppose this is Anjali's machine. Anjali should know the address of Rahul first, right? And this is the address of Rahul, 192.168.10.20. What is my address? My address is 192.168.10.10. It is as simple as that. Let's, and sure, they are talking. So what is the meaning of this ping command? The meaning is that you are sending some packets from 192.168.10.20 machine and you are getting reply from 192.168.10.20. If you are getting these replies back, it means that 10.10 can easily able to communicate to 10.20. It is as simple as that, right? Interesting. But now it is worthwhile to check that what do we have in ARPs, right? Because it is so fast, the process is so fast that it didn't let us know that it is doing ARP or not. Let's do ARP minus A. And interestingly, you can see here, previously this was empty, totally empty. But now we can see 192.168.10.20 physical address is this one, right? And it means that somebody is this host A, which has done the ARP and it is getting these IP addresses, sorry, a MAC address corresponding to this. And this is the dynamic. It is learning it dynamically, right? Similarly, if we see on this machine, definitely this machine is going to have learned the IP address, sorry, MAC address corresponding to 10.10. Why? Because ARP message flows to host B, right? If I do ARP minus A here, sure enough, this machine has learned the MAC address corresponding to 10.10 because the ARP message, the broadcast message went from host A to host B. It is as simple as that, right? Interesting. And you all know that the last four digits of my 10.10 is AAA, and that is what we have given it deliberately, right? So that we can identify it. Very, very interesting, right? And now if you see, we have just connected two hosts. We know how these two hosts are communicating. We know the theory behind it too, right? We should know the each and every step, right? If I log into this switch also, right? And now this is going to be very, very interesting that what switch is doing, right? You all know switch builds its MAC address table on the basis of whatever the information you are sending from here, right? So first thing first, when you send this ARP message from here to here, what that ARP message contains? Of course, ARP message is going to contain many things. Sender MAC, sender IP, target MAC, target IP, you all know from the theory classes. And this is going to be encapsulated in source MAC and destination MAC because this packet was the ARP packet which needs to be delivered to everybody so that everybody can be sending back messages to you, right? I'm not writing all the contents of it because you must have learned about all this in the previous class. If I talk about source MAC is going to be A, and the destination MAC is going to be all Fs. You all know all Fs means the broadcast address. And once this switch receives this ARP, you know that switch is building its CAM table. And inside this CAM table, there are three entries, right? First entry is VLAN, but we haven't talked about it, so we are not talking about it now. The second entry is the interface, and the third entry is the MAC address. It will say, because now this switch knows that MAC address A is connected to its 0/1 entry. Why? Because host A just sent an ARP message, and switch is intelligent enough to create this table because it just receives a message from host A, and host A MAC address, switch understand MAC addresses. Switch understand that okay, this is A.A.A.A, and I am receiving this on my FA0/1 interface, and that is why it has written 0/1 here. So it means that it is very straightforward for switch to understand that the MAC address A.A.A.A is connected to this one. And when switch sends this broadcast here, this guy is going to reply with the ARP reply, which is the unicast message. But that message also contains the source MAC address of this guy, right? Source MAC address of host B is BBB. And that is why you are going to write here BB is connected to 0/2 port, FA0/2 port. It is as simple as that. So now let's see whether switch is working, switch is working just like what we have read, right? So what I'm going to do is, again, I'm going to click on this switch, and this switch is going to give me this console, right? Interesting. And now I want to interact with the switch. So believe me, you just need to click on this CLI portion here, and it is going to give me this console. This is what we were talking about. Right now, if you see that I haven't done anything on this switch, I just click on CLI, it is going to give me this switch. It is saying it's a switch with this greater than sign. What is the meaning of this greater than sign? The meaning is I cannot do much here. Right now, I am into exec mode. First, I need to go to privilege mode, means this hash. If I want to do this, right? If I want to do if I want to some more closer thing into the switch, right? Interesting. So inside, if you come here, and if you do a question mark, I just have written here question mark, right? It is going to show me that these are the only commands which are available from this mode. You cannot do much. You cannot do much, right? Extremely sorry for this. Okay. Yeah. You cannot do much here. So that is why if you want to move from this mode to another mode, the other mode is going to be your privilege mode. What you need to do is you just need to write here enable. And by the way, I haven't set up any password, so it will let me through the enable mode. And now you can see that there is a hash mark. Hash mark means that basically this is your, what we can say, this is your configuration mode, right? Sorry, the privilege mode. And by the way, the first command I would like to do here is I just want to check show MAC address table, what this device has learned, right? So if I do show MAC address table, it is going to give me that yes, there is nothing in because we just got late. This MAC address tables got actually erased after every 5 minutes, and from last 5 minutes after this ping, we have been talking, right? So what I do is I will try to do the ping again from this host A, right? Let's do the ping again here, and let's see that what we are learning in the switch. And if I do a show MAC address table again, and sure enough, you can see the switch has built its CAM table. It is a good experiment to do, right? If you see here, Just wait a minute. I'm not sure where my Epic pen. Here it is. So if you see here, it is saying the MAC address, which is AAAA. It has learned it dynamically, and the port through which this AAA is connected means host A is connected as FA0/1 and host B is connected to FA0/2. How it is building it? On the basis of source MAC addresses. This is as simple as that. I want everybody to raise hands if they understand how two computers are going to talk when they are in the same network. Perfect. If you have any doubt, any question, this is the time to ask. Anybody, any doubt, any question? No, yes?
Yeah, Vishnu, we have one.
Please, please, please.
Vishnu, yeah, we have one.
Yeah, what is your name, first of all?
Yeah, okay.
Yeah, I'm Sanjana.
Hi, Sanjana.
Yeah, actually, I got request timed out when I gave ping 192.160%. I did this. I did not do it. When I gave that command, I got request timeout for long.
Okay, so for that, basically, I need to debug that what exactly you are doing, right? But I'm pretty sure.
Let me check that. Yeah.
Perfect. So I'm pretty sure that if you follow these steps, whatever I have done means in your free time, you are not going to get the request timeout. Maybe something somewhere you have misplaced something. Okay. Anybody else have any doubt over this? No, yes. Okay. So let's go somewhat deeper into it. And what we are going to see that whatever we have learned just now, believe me, there is a way in the packet tracer to simulate that. And we are going to simulate it, right? You must be wondering that we just simulate it, right? But packet tracer has some more capabilities, right? Interesting. And let's see those capabilities now. I am going to delete everything from here, right? What I am going to do is I will be making this system going into scratch mode. So basically still you can see that every MAC address table is here. So I will be clearing the MAC address table. The command to do this clear MAC address table. And by the way, nobody can remember all the commands. Okay. You will always have Google with you. You can always check the documentation. So no, do not means maybe to pass the exam, you need to memorize some of the commands, but nobody can learn all the commands, right? And that is why it gives you the Cisco IS gives you many things. For example, if you forget that what was there after Mac, right? You can do the question mark and it will complete you, right? Or you can do the tab also, it is going to complete you. So clear MAC address table. If you do that, and if you see here, show MAC address table, it is cleared. What we are going to do here is I will be clearing the MAC addresses from host A and host B too, right? So right now I'm in host A. If I do ARP minus A, it will show me that it is learning. So how to delete this file, right? You need to do just ARP minus D. And if you do the ARP minus A again, it won't show you anything, right? And why I'm deleting, I want to make the system to its base settings, right? Base settings means now I want to showcase you that what exactly happens behind the scene, although I have explained it many times, right? But if you do not know for any other protocol, for now you know that how two computers going to talk when they are in same subnet, different subnet, right? But if you do not know any protocol, then you can learn through the simulation mode. So what you need to do is you need to click on, first thing first, you need to click on this simulation mode, right? Here we have this simulation mode. You need to click on this, right? So let me click on that. Delete it. Simulation mode, right? So this here we are in the simulation mode. What we are going to do is now I will be showcasing you how actually the packet is going to be there. So I need at least one volunteer from now. So maybe let me choose Astha Joshi. Are you there?
Yes, I'm there.
Yeah. Thank you so much, Astha. So basically, what I will do one task to you, and you need to just remember it. Okay.
Okay.
So here you go. Means we have this topology, right? We all know that. And now what I'm going to do is I am just clicking this host A, right? Host A, and I am going to raise a ping. And right now I am in simulation mode, right? So what is going to do? See, it has built two packets and here, right? And this is done by the system itself. So if you see here, it is generating two packets, the light green packet and the dark green packet. And if you can see inside what is there, so if I click on this light green packet, it is saying me, actually, this is my uh, ping packet, right? I just clicked on this, the light one, right? So what is happening
Yes.
here is that this, and this is the way you should learn networking, right? It is saying that it is the layer 3 generated packet. Source IP is 192.168.10.10. Destination IP is 10.20. It is an ICMP message because you know the ping uses a protocol which is known as ICMP and is an ICMP echo message. And at layer 2, if you want to see that, and basically it is going to say everything, right? The ping process starts the next ping request. Everything is written here. And believe me, if you understand this, right, this is going to be great. So by the way, the source IP packet address of the, I haven't specified it. So the device sets its IP address to its port IP address, whatever we have here, right? Whatever we have given here. We all know that the packet which is going to come out, the IP packet which is going to come out from here is going to be 10.10, the source IP address, and 10.20 is the destination IP address. But we cannot fill the source and destination MAC, and that is why now the light green packet will be inside the memory, and the green packet, let's see what is the dark green packets, right? So let me delete this and let me click on the green packet itself, and it is very interesting that it is showing you, okay, this is good. So now, because we cannot send the light green packet because it is not complete in terms of MAC addressing, we are sending this packet, which is the ARP, right? Here, if you can see, this is the ARP message, and source MAC address of this ARP is A.A.A, and the destination, because we do not know, and that is why we are going to put it here. It is all F's, means the broadcast address. You all know, right? It is going to showcase you step by step of what is happening. Firstly, this light green packet cannot go because it does not have the destination MAC address because we do not know. And the system is taking the help of this R packet, which is the dark green message, right? So Asthaji, for you, the thing to remember here is that the green packet is the ARP one, the dark green packet, and the light green packet is, let me in, somebody is waiting. So, and the light green packet is the IP ping packet. Okay, Asta, will you remember that for me?
Yes, sir.
Okay, very good. So we will be needing it maybe sometime later. So the dark means ARP, right? And the light means your IP packet or the ping packet.
Yes.
Okay, perfect. So here you go. This was the first step when I wrote down, when I write ping 192.168.10.20 on host A. Host A is going to generate these two messages of different colors, light green and dark green. And now, if you click on this play button, it is going to showcase you the next step, right? So according to you, what should happen? It should be the green packet, the dark green packet should go out and reaches to here, right? Do you all agree with me? I think you all agree with me. Let's do a click on this play button. Where is the play button? If you can see on the right hand side, right here, we have this play button here. I'm going to click on that to move ahead in the next step, right? So I am clicking on this play button and it is going to send this green, dark green packet, which is the R packet, which is reached to the switch, and the switch is broadcasting it to the host B. You can see it, right? And host B should unicast the packet and it is going to send it towards the host A. It is as simple as that. Now I have stopped the simulation and it is saying that the green packet has come back here, right? And now it can create this. What is the meaning of this green packet is coming back? Because this is the ARP request which has gone from here to here, and ARP reply has come from here to here. And by these ARP request and reply messages, Switch is very intelligent enough to know that who is connected to where, right? It is building its CAM table. Previously, there was nothing in the CAM table. But now host A and host B knows what is the MAC address of host B. Host A knows what is the MAC address of host A. This is now known by host B. It is as simple as that, right? Because ARP is done. Now what is going to happen as the next step? Next step, now your light green packet, and the light green packet was which one, Asta?
Light green packet is the IP or ping packet.
Yeah, this was my IP ping packet, right? So now in the next step, previously what was the problem with the light green packet? The light green packet has a source and destination IP. 10.10, 10.20 was there for sure, but it didn't have the MAC address. It had its own MAC address, A.A.A, or it didn't have the MAC address, right? But now this packet, the dark green message, which is the ARP reply, through ARP reply message, this host comes to know, okay, the host B MAC address is BBBB. Now what should happen? This green packet should go out on this wire. It is as simple as that, right? So let's again click on the play button, and this time your green packet should go, the lighter packet should go out, right? Let's see that. Here you go. And it should be forwarded by the switch 1. And here it is. This is the ping message, and the ping reply will be sent by the host B, and host A should get it. As simple as that. Now I have stopped, and it is saying that the packet path is complete. And by the way, on the right hand side, if you see every packet, you can see here, this was the first thing where we began, right? And what at what device happening what? Actually, it is going to showcase you everything here, right? For example, the third packet, right? This one, generated by this host A, right? These are the two packets generated by host A, and host A is going to send the ARP message, which is going to out here. This is the ARP packet, right? It's the broadcast frame. Similarly, what is going to happen at switch 1? What is going to happen at switch B? How switch B is replying to it, right? What is going to happen again at switch 1? Everything is right here. Just go step by step and you will be amazed to see that the thing which you have just read in initial 13 to 15 hours of the CCNA, right? Everything is going to make more sense if you do this. Very, very easy, right? But this is going to be easy if you understood each and every line, every single statement from lecture number 0 to lecture number 4. It is as simple as that. So what we have just learned, we have seen that this is an important, the greatest tool, right, to start your networking journey. Even if I give you the real routers and switches, believe me, you are not going to learn this much because packets are there. Everything is there. For example, if I showcase you this packet, right, which is coming out, it is showcasing you OSI model. It is showcasing you What exactly the packet look? This is the Ethernet. This is the ARP. Everything is there, right? This is how you can see the packets in Wireshark too, right? Very, very simple and very, very interesting too, right? Now, what we are going to do is we are going to increase this topology. Now I am coming again into the real-time mode, right? I am again into the, I just click on the real-time mode. What I will do now, I will extend this topology, right? Right now what we have just simple two hosts, right? And believe me, if you connect more hosts to it and give the IP address from the same segment, everything is going to communicate, no problems, right? But that should be part of only one network. What if you have another network here? You are going to introduce a router too here, right? And that is what I'm going to do here. So what I will do now, by the way, I know that the time is way over 1 hour, but the extremely sorry that I need to teach you to 1.5 hours in the beginning. And the reason is I have some other meetings which I need to take, right? But yes, you can definitely take a half an hour break after this. And the moderators there are going to play the remaining 1.5 hours for you, right? So having said that, let's increase or let's extend this topology. Now what I need is I need another switch. So what I'm doing here, I am going here in the router switches area. I am introducing one more switch. One more switch is here, right? And then I want to introduce AND host. There are two PCs, this PC and one more PC, this one. And of course, I want to connect them with this switch. And you all know I do not want to waste my time in learning crossover or those cable. So I will be connecting it using this. And why this symbol is orange on the switch side, you will come to know when we will talk about the spanning tree protocol. So this is going to be my host C, right? And here, this is going to be my host D. And this is going to be my switch 2, right? So let's configure the IP address is also here for the host C also. Host C is in totally different network. I want to again, let me, you know that this network is your 192.168.10.0/24 network. This network is totally different network, right? This is 192.168.20. The third octet is changed here. Do not get confused with the IP addressing, right? This is 10.10. This is 10.20, right? The starting two octets are 192.168. You all know, right? Here, the host C, this is this network. Host C is going to be 20.10 and this is going to be 20.20. Host C, D are part of totally different network. And if you want to connect them, you need to have a router here, right? So let's introduce the router here. So we have this guy, one router we are introducing, and let's call this router as R1 according to our topology, right? And now I will be connecting this with this switch. Switch has a lot of ports, so let's connect it. And here also, I'm going to connect it from here to here. It is as simple as that, right? So this is my gigabit 0/0 port, the left-hand side, and the right-hand side port is this one. So what I'll do, if I give you the configuration, I need to go to this host C to say your IP address is going to be 20.10. The complete IP address is going to be 192.168.20.10, right? Then host D is going to be 20.20. And you all know that now I need to define the gateway also, because now we are talking to different networks. First thing first, if I do a ping now in host A towards 192.168.20.10, suppose in host A, if I write this command ping, then host A immediately come to know that 192.168.20.10 network is not, host is not inside my own network. Suppose this is network number 1. Host A will immediately come to know that 192.168.20.9 is not part of my network, for sure. And if it is not part of your network, then host A will send the packets towards where? Towards the gateway or towards the router. And that is why we have introduced this router, and we are going to give the first IP address of this network to the router interface gigabit 0/0/0. And that interface, how to configure, I will let you know, but the IP address going to be here is 192.168.10.1. The first IP address generally we give to the default gateway. Similarly, this interface is going to having 192.168.10.20.1. It is as simple as that. /24, of course, /24, of course. 10.1 is part of this network, of course. 20.1 is part of this network, absolutely. It means that what extra configuration I need to do, I need to define the IP address, of course, here. I need to define the gateway also, of course, here, right? And of course, host B and host A, I haven't defined the gateway till yet. I will be defining that your gateway is 10.1. If you want to communicate to different network, just go to the router, and router's responsibility is to send it to the final destination, right? Similarly here in host C and D also, I need to define the gateway. It is as simple as that. So what extra configuration I need on host C, or what configuration I need on host C? I need to define its IP address with mask for sure, and it is going to be 20.10/24. I need to define the gateway for it, which is going to be 192.168.20.1, the first IP address I have given to this interface. I need to give the MAC address because we have been doing it. For host C, the last 4 digits are going to be CCCC, and host D, the last 4 digits are going to be DDDD, right? I need to do that for host A also. It is as simple as that, right? But I have already defined IP address and mask for sure already for host A. I have defined the MAC address for host A, no doubt about it. I want to define the gateway now, which is going to be 10.1. It is as simple as that. And now, and after that, I need to configure this router gigabit 0/0 interface with this IP address and this with this IP address. And then these two hosts can easily going to communicate with each other. As simple as that. Interesting, right? So let's do that. Let's configure them, right? So I am into the host C first, right? Let's move it here slightly. I am into the host C. Let's go to the config, and in the config part, let's go to the first of all here. This is going to be CCCC, you all know, right? IPv4 address is going to be 192.168.20.10, and I will deliberately make some mistakes. I know it's 1.5 hours, so please try to correct them. Okay, am I correct here? I just need your hand raised. Am I correct here? Okay, perfect. I need to define one more thing here. The interface, uh, basically, we are done with this one. This is good. And default gateway also I need to define 192.168.20.1. 20.1. It is as simple as that. And let's see whether we are seeing the changes here, right? If I do ipconfig here, and sure enough, I have 20.10, I have mask specified, I have gateway specified. So we are good to go here. Let's open host D. Let's define its configuration. The first thing first, maybe I can define the gateway here, right? Which is going to be 192.168.20.1. And let's define the first Ethernet addresses, which is going to be 192.168, sorry for this, 168.10.20. Anybody has any doubt in this? The IP address of host D will be this. Everybody agrees to this? Guys, come on. What should be the IP address of host D?
Like it should be 20.10.
It should be 20.20 because 20.10 is given to host C, right? But thank you so much for replying. This should be 20.20, right? 20.10 is given to host C. Having said that, let's see that we are getting it is going to be IP config, and here you go, it is 20.20, right? And in the meantime, again, I can configure the host A address also here, right? So if I go to the config, and here I should specify at least the default gateway here. Now I am into the host A. I want to, previously I didn't give the default gateway because we were communicating inside the same network, but here I need to give 10.1. So this is done, okay? And similarly host B also I want to define the, here you go, config and interface default gateway 192.168.10.1. As simple as that. Let's see, let's check whether it's working. IP config, and sure enough, we have the default gateway. Okay, now what is remaining? What we have done till now? If I open the Epicman, we have done the configuration of host A, host B, host C, and host D. We have defined the host A default gateway is .1, which is right here, and host C and host D default gateway is right here. This is my router 1. So let's configure router 1 gigabit 0/0 interface and this interface. So there are some new concepts when you are going to configure the router. It is going to give you the operating system, right? You all know that there is an internetworking operating system, which is also known as iOS, right? So let's open configuration of, let's open the CLI of router. And here, if I am saying that router as greater than symbol, I am in the user mode, user execution mode, and I need to change it to privilege mode, right? How I can change any parameter in this router? For that, I need to come to the configuration mode. Means I am saying this router, I want to configure you, right? First thing first, I need to give the host name of this guy. Right now it is just the router. I want to give the host name as R1. So now you can see the host name has changed. It is now R1. And now I want to set the IP address of gigabit 0/0/0 interface. So I need to go to say that I want to set the interface IP address. That is why I am writing interface. I need to say gigabit 0/0/0, right? So if you can see here, now I am in the interface mode, right? It's very, very easy. Right now you can, maybe it's a little bit overwhelming for you, but believe me, it is really easy. Okay. So what I did is I was into the enable mode, first thing first. Then I write, the user mode. Then I come to the hash, which is the enable mode or basically the privilege mode. And now I have writing down configure terminal. If I write configure terminal, the meaning is I want to configure this router, right? I have specified the name, which is host name, R1, And then I am saying that I want to configure your interface. Which interface? This interface. Is as simple as that, right? And now I will be giving it an IP address, which is IP address 192.168.10.1, and the mask is going to be 255.255.255.0. It is as simple as that, right? By default, this interface is in shutdown state, means you are administratingly shutting it down. By default, it is the case, and that's why you need to write no shutdown here. And now this interface is up. You can see that the green, it moved to green color. Previously, the color was red, but now if you can see, this has moved to green color. If I configure this interface also, this will move to the green color, right? So let's do that. So here you go once again, router. And what I want to do is now this time, I want to configure interface. By the way, through any mode, if you want to come out, just type exit, right? Now again, I want to configure the interface. Which interface? Gigabit 0. And by the way, you can write directly gig 0/0/1 if you want to. And do not get overwhelmed with this, because all these commands can be, you can get it from the internet or from the configuration guides, which is available on many courses, right? I will guide you. Do not worry about it. So interface, and then I will write IP address. What should be the IP address? 192.168.20.1, because it's a separate network. 255.255.255.0, and no shut. Just see that the red symbol is going to be green when I type no shutdown. And here you go, right? This interface is now up and running. How to check? If you just come out, you can write the end or exit, right? Now again, you are in the user, privilege mode. You can see that what you have configured just now, show IP interface brief. If I write, it will be showcasing me that what I have just configured. And I have configured the IP address of gigabit 0/0/0 on this router. This one and this one. It is as simple as that, right? And we have talked about some of the routing also. So I should see that there are two connected routes in this router, right? So if I write down show IP route, you can see that there are going to be two connected routes here. What are those connected routes? One is 192.168.10.0 is directly connected to gigabit this one, right? Because you manually configure the IP address. Similarly, 20.0 is directly connected. What is this entry with the name L? You will come to know later, maybe later part in your career. This is again important, but we are not talking about it. We are just talking about C entries or the connected entries. Very, very simple, right? And now if you do a ping from host A towards host B, right? Or maybe host C. What is the IP address of host C? Anybody can remind me? I am in host A, by the way, now, and I want to ping host C, right? So host A to host C. Anybody want to remind me what is the IP address of host C? Anyone? 192.168.20.10. And it is not pinging, right? Or maybe we should wait. And yes, the first ping was dropped, but now it is pinging, right? I can ping 20.20 also. So by the way, I have, and why this ping is dropped, the first ping is dropped, I think you should think about it, right? And this is a homework for you. And what we have done till now, we have actually were successfully able to communicate from this host A to host C and host D. And by the way, host C and host D are not in my own network. These are part of completely different network, right? And that is why we need routers. And if you can connect to different networks, believe me, you can connect the entire world. You just need different routers. For example, you can create one network. If I open my, right, so uh, so what you need to do now is you can create your own network here in India, and maybe somebody can create their own network in US. And basically, if you have multiple routers which are connecting, then maybe this is R1, R2, R3, R4. Entire world can be connected like this. You just need to understand how to communicate, how to host communicate when they are in same network, and how to host communicate when they are in different networks. It is as simple as that. I hope that you get at least something out of today's lecture. And if you repeat it, it is going to be great. So I just need hand raise from everybody, or maybe means whoever get at least 50 to 60% of today's class. Okay, this is great. This is great. Thank you so much, guys, for your time. And I am just stopping the recording. See you soon.